Okay, it's time to apply some of this stuff to some real life. There's two types of problems we're going to go over in this. Two runners run for equal amounts of time. The first runner runs a distance of 1,600 meters. The second runner runs a distance of 1,400 meters. The first runner averages 5 meters per second faster than the other racer. Find the time each runner traveled for. Now there's only one answer because they traveled for the same amounts of time. Now we're going to use something we haven't used this year at this point, and this is the DIRT formula, okay? DRT, distance, rate, time. Distance, rate, time. Whenever you're dealing with distance, rate, time, you want to make a box just like that. You're going to split it into 3 columns. This box here is for runner number 1, and this is runner number 2. Okay, we're going to put distance here. You're going to put rate here, and rate is per. That's what a rate is. This much distance per this much time, and this is the actual time. Now the distances we know runner 1 went 1,600 meters and runner 2 went 1,400. So ditch those, cross them out. Now the rate. The only thing you know about the rate is the first runner averages 5 meters per second faster than the other runner. Okay? So this guy here, you don't just put 5, you put plus 5. Because faster means more, it means plus. So we don't know what plus 5, so we use a variable. You can use x, I'm going to use r here, okay? And this is just r without the plus 5. Now time, this is the answer to the problem, okay? We know that these are going to be of equal value because they travel for the same time. Now, you have to know this formula for time. It's the distance divided by the rate, okay? So, we know the distance for this guy was 1,600. Now the rate we don't know, so we're not actually able to divide, so we just put the expression r plus 5. And then the same thing here, we know his distance was 1,400. We do not know his rate, but we have represented that with the r variable. Now we know those are equal, so make an equation, a proportion where they're equal. 1,600 over r plus 5 equals 1,400 over r. Okay, so now you don't use the common denominator method. When you have just one ratio on each side, it's a proportion. You use A times B, and that's always equal to C times D. This times this will always equal this times this. So I set up an equation and I put 2 factors on each side with times. This is A, this is B, this is C, this is D. So A is 1,600, and then B is just the R variable. C is 1,400, and then D is R plus 5. Okay, so this is just 1,600 times R, or 1R, it's 1,600 R. Over here you have to distribute because there's a plus sign. So 1,400 times 1R is 1,400 R, and then 1,400 times 5 is 7,000. So you're solving for R. Now R is only to the first power. There's one answer, okay? So you're going to use linear properties. Okay, so take out your smaller r. Don't clear one side, that's factoring properties. And that's 200r equals 7,000. Then you just divide both sides by 200. And that's going to be 35. Now that's not your answer, that's your rate, not your seconds. Now what you do now, the hard work's done. Take out these r's in the time column and replace them with your answer, 35. Now these are going to be equal when I divide. First I'll do 1,400 divided by 35. Got 40, okay? You put that down there, that's your answer. Now to check your answer to see if the other one's the same, you take 35 plus 5 first, which is 40. And 1,600 divided by 40 is 40, so they're both 40. So that's the number of seconds. Okay, we're going to do another one just like it. Two race cars travel for the same amount of time. The first car travels a distance of 900 miles. The second car travels a distance of 800 miles. If the first car travels, that should say travels, I didn't put, just he travels 30 miles per hour further than the first car, than the second, sorry, I put second. I wrote this like a moron. The first car travels 30 miles per hour further than the second car. Remember, further means plus. For how many hours were they traveling? So again, it's distance, rate, time. Okay, so you got car 1, car 2. You got your distance, your rate, and your time. Okay, the distance, well, 900 and 800. Now, again, rate means per, so you look up your per, but it's 30 miles per hour further than the second car. That doesn't mean you just put 30, you put plus 30, and the plus 30 always goes with the one with the higher distance, okay? Obviously, its rate would be the faster one if it went a further distance. So then R and R. Okay, so your time, you know the times are equal, and then you know that they're expressed as the distance divided by the rate. Okay, so 900 divided by R plus 30. So you never actually are able to divide until you find your R answer. Then 800 over R. Okay, now line those up into a proportion. So 900 over R plus 30 is equal to 800 over R. Okay. So A, B, C, D. So A times B is equal to C times D every time. When you have an equals and there's one ratio on each side, the cross products and the proportion always are equal. Okay, so the A is 900, the B is the variable R, C is 800, and the D is the variable R plus 30. Okay, so multiply that. 900 times 1R, that's 900R. Now over here you got to apply the distributive property. 800 times 1R is 800R, and then 800 times 30 is 2,400. No, sorry, 24,000, my bad, I'm missing a zero, 24,000. Okay, and you're solving for R. Only one answer, because the R's are, both of them are just to the first power, so that's linear properties. So take out your 800R, 100R, and then 24,000. You divide by 100, divide by 100, and R is 240. Now that's not your hours though, that's the rate. So what you do at that rate is you put it here, and then you take 800 divided by 240. Okay, that's fine that I got that. Okay, you can put 3.33 or 3 1/3, it doesn't matter to me. Now if you want to check your other answer, make sure it's compatible with this, you know that 240 plus 300 is 270. Now take 900 divided by 270, and hopefully that's exactly the same thing, and it is. Okay, why don't you pause the video here and do problem number 1, okay, because that's what you're dealing with. You are going to get a kind of weird looking answer here. It's going to be 0 point something in the end, okay? You are just, they're going to be weird answers. Just round the decimals when you get them, okay? Go 2 decimal places out. So don't say, am I doing this right? You will get a weird answer for R, possibly, and you're also going to get kind of a weird answer for your hours. Just stick to the process. Pause video and do it. Okay, hopefully you figured that out. Now we're going to learn our second type of problem. This is what number 2 entails. So far I've made 40 of 50 free throws. About how many free throws do I need to make in a row for my average to hit 90%? This is average, okay? Average is also proportions. What you do is you take your 90% put the percent sign, and that percent is a ratio because it can always go over 100%, 90 over 100. Now, so far we got 40 out of 50. Now that's not equal. These are not equal because you see, that's 90%. Is 40 out of 50 90%? No, that's 80%. So what you have to do, you have to add to how many free throws you make, X, because that's the answer to the problem, but then that also automatically adds to the same thing to the number of free throws attempted, okay? Because think of it like this, big if you shoot your next free throw and make it, then you've made 41, but you've attempted 51 now. It doesn't just stay 50. If you make your next two, you've made 42, but then you've attempted 52. So every time you add one to your makes, it also adds one to the attempts. Okay? So, and you can again apply the A, B, C, D. Okay, so we'll be taking A times B, and then we know that that's always equal to C times D. So A is 40 plus X, and B is 100. C is 90, and then D is 50 plus X. Okay, you have to distribute here because you have a plus, okay, drop that. And you distribute backwards, you take 40 times 100, and then 1X times 100. 40 times 100 is 4,000, and then 100 times 1x is 100x. Now over on this side, okay, you also have a plus, so you need to distribute to two separate terms. That's one term times two terms. 90 times 50 is 4,500, and then 90 times 1x is 90x. So x is only going to have one answer, so you use your linear properties to solve it. Okay, got x on both sides. Don't clear one whole side, you just clear out one of the x terms. 90, I usually go with the smaller one. Think you'll be happier that way. So you have 4,500. Then you have 4,000 plus 10x, or you can write 10x plus 4,000, doesn't matter. So now on the x side, you got a plus operator, and this is times. So you take out the number you're adding, the 4,000. It's positive, so you take it out with subtraction. 10 times x equals 500. Then you divide both sides by 10, and x equals 50. So this dude has to make his next 50 free throws in a row to get his average to 90%. Okay, 40 plus 50 is going to be 90, 50 plus 50 is 100, so 90 over 100 is equal to 90 over 100, okay? Next problem, going over another one. So far I've made 20 of 30 free throws. How many free throws do I have to make in a row for my raise my average to 75%? So that when the average is expressed as a percent, you know that as a ratio, that's 75% over 100. That's always how a percent is made into a ratio. This guy's made 20 of 30. Was 20 of 30 equal to 75%? No. Look at that. That's 66.6 repeating. So you add to the number you make, but that also automatically adds to the number you attempt. Okay? And then we can lose A, B, C, D. Okay, so I know that taking the A times the B is equal to taking the C times the D. So the A is 20 plus X times B, which is 100. You got to know that this is A, this B. You can't go A, B, C, D. That doesn't make any sense, okay? Then C is 75 and D is 30 plus X. So you slap ones in front of your X variables and you apply the distributive properties. So you take 100 times 20 and then 100 times 1x. So 20 times 100 is 2,000. 100 times 1x is 100x. Then over here you also got a plus operator, so that means you have to distribute. 75 times 30, 2,250. And 75 times 1x is 75x. So you're solving for x. It's only to the first power, so you're applying linear properties again. Okay, so you take out one of your x's. I'll go after this one. Minus 75 from 100. So 2,000 plus 25x equals 2,250. Okay? All right, so you got x over here, you got plus and times. So you take out your 2,000 by subtracting 2,000. That's 250. And you divide each side by 25. And that's 10, so x equals 10. So that's not quite as crazy. You'd make your next 10. Because if you made your next 10, that would put you at 30 made, 40 attempted. So 30 over 40 is 75%.